Alright, this next problem is going to involve more than one trig function in the same equation. Okay, so here we have an equation that involves both the cosine and the sine together. Now often what we're going to try to do is limit ourselves to one function eventually using some trig identities. Those could be the Pythagorean identities or the cofunction identities or reciprocal identities or something like that. Some way to work this down to one or maybe two if needed trig functions. Here I've got cosine and sine, and this equation actually almost looks like a Pythagorean identity, except that it's not. The Pythagorean identity says that sine squared plus cosine squared equals 1. This says cosine squared equals sine squared plus 1. And so we're looking for the angles theta in which this occurs. This isn't always true. What I would do is suggest using a Pythagorean identity to try and eliminate one of these two trig functions. Try to turn the cosines into sine or sine into cosine. And so maybe we'll try that Pythagorean identity, right? The cosine squared theta plus the sine squared theta equals 1, or sine squared plus cosine squared, however you want to write that. Well, if I were to solve for the cosine squared, this is an identity, so this is true for every angle. It doesn't matter, I'm not solving for a particular angle there. If I were to get cosine squared by itself, I'd have to subtract off the sine squared theta. And so we know that the cosine squared theta is 1 minus the sine squared. Right? So that's still a Pythagorean identity, just an alternate form. And so that's what we're going to do. I'm going to replace this cosine squared with something I know that it's always equal to, right, for every angle. So I'm going to have 1 minus sine squared theta is equal to sine squared theta plus 1. All right? Okay, that's good. That gets us a good start. Now, let's try to group our sines and our ones together. Well, actually I could subtract 1 from both sides. Subtract 1, subtract 1, and they actually all cancel off. All the ones cancel off. It's kind of interesting. So I end up with negative sine squared equals sine squared. Let's try to get the sine squares on the same side. So I'm going to add a sine squared to this side and to this side, just to get all the sine squares on the same side. So I eliminate them off the left. That's everything gone from the left side. And now on the right side I've got sine squared plus sine squared is 2 sine squared, right? Well, 2 times something equals 0. If you divide out the 2, you just get that thing, the sine squared equals 0. So I'll divide out the 2, and that's equivalent to the sine squared of theta equaling 0. Okay? So now we're just looking for all values of theta that make the sine squared equal to 0. Well, if you square something and you get 0, then the thing you squared must be 0. So I could use the square root property here to verify that further, but really this is implying that the sine of theta must be 0. I don't need the plus or minus on there because it's 0. So now we're looking for all values of theta where the sine is 0. Okay. Well, remember sine starts at the origin, starts at 0, goes up, down, back up. And so when it hits 0, it would be at 0, at pi, and at 2 pi. Or we're working in degrees, aren't we here? I want to solve this on the interval from 0 to 360, rounding to the nearest tenth. So I don't want pi and 2 pi. I actually want 180 and 360. Now we're not actually going to hit 360 because I don't want it in the interval. So we're just going to focus on 0 and 180, as the two answers then. So theta equals 0 degrees and 180 degrees. All right. I didn't have to go to my calculator on that one. I could have. Had I gone to my calculator, I would have needed the inverse sine, correct? Just to show you something real quick, I could have gone with this. Oops. I could have said that theta is the inverse sine of 0, right? That's how most of us would solve this problem at this point, is to do that. The problem is, if you type in inverse sine of 0, and I'll pop this in degree mode. Well, the inverse sine of 0 gives you 0, oops, on the calculator. But it doesn't give you that second angle of 180. And that's because of the range of the inverse sine being from negative 90 to 90, or negative pi over 2 to pi over 2. And so we'd be missing out on this extra angle of 180 if we just use the inverse sine feature of the calculator. So you do want to be careful. You can use that, but you just want to be careful to hit every angle on the given interval that satisfies the equation, not just the ones that come out of the calculator. If you're just going with the calculator answers, you're probably going to get some wrong. You'll be missing some of the quadrants that do satisfy the equation but don't show up on the calculator.